Now we're going to do chapter 2. We're going to review the material we had in chapter 2. So after you watch the videos on different modules of chapter 2 and watch the exercises, this video would be a summary of what you have learned in chapter 2. Chapter 2 is talking about functions and their graphs. So to start with, it talks about the Cartesian coordinates. Cartesian coordinates is a two-dimensional coordinates. You have an x and y axis. Horizontal axis is called x. Vertical axis is y. Any point on the flat surface, such as point A, is identified by the x coordinate, let's call it x1, and a y coordinate, y1. So A has a coordinates of x1 and y1. So if you give the coordinates of a point, you can identify where it would be on the flat surface. So that is the Cartesian coordinate to begin with. Next, you have the slope. So on the Cartesian coordinates, again, let's just take one quadrant number 1 of the Cartesian coordinate. Again, you understand it continues here and here. Here's your x-axis, here's y-axis. So I'm just showing this. So if you have a line, such as this L, you pick 2 points on this line. And drop one to the x-axis and one to the y-axis. As you go from point A to point B, you're going up and you're going to the right. So the part that is going up is called the rise, that is measured in y, change in y, and the one that is going horizontally from A to B, which is this distance, is called change in x. And the slope, which shown with M, would be rise over run, which in this case would be equal change in y over change in x. So if you say the change in y is measured from A to B, so you measure it on the x-axis. So here is y1, here is y2, and for the x, here is x1, and here is x2. Therefore, the slope would be equal to y2 minus y1 divided by x2 minus x1. So this would become a formula in calculating the slope of a straight line. Now, linear functions. Well, first of all, let's talk about functions for a moment. Functions are like input-output system. So if you say y is a function of x, that means as x changes, it would cause y to change. X would be called your independent variable, and y is your dependent variable. Okay? So independent variable and dependent variable. So y depends on x. Now this relationship can be linear or it can be nonlinear. A linear form of a function would be like y equal mx plus b. where m is the slope of the line and b is the y-intercept. The y-intercept. Okay, so when you graph this, you're going to get a straight line with the slope being positive. If the slope is positive, then when you graph it, you would get a line that is going upward from left to right. So here is your x, here is your y, and L1 has a positive slope. A negative slope is when it's going downward from left to right. So L2 has a negative slope. L2 has a negative slope. So you need to keep that in mind when you look at the line, which one has a positive and which one has a negative slope. The relationship between two lines, well, let's just look at this one for a moment. Relationship between two lines such as L1 and L2. One would be that they would cross each other. That means they have a common point between the two of them, such as point A. Right? So two lines can cross each other. That would give them one value. Again, A has a coordinates of, say, x1 and y1. So that point with the coordinates of x1 and y1 would be in common between the two lines. And that's the only place, by the way, they cross each other. Since they are lines, they will go away from each other as they continue. Same thing with L1. They will go away from each other. So the only common point that they would ever have is this point A. Now, two lines can also have similar or the same slope. In that case, the two lines would be parallel to each other, such as L1 and L2. The relationship between L1 and L2 is that they have the same slope. They would have a different y-intercept. One of them would be, say, B1, and if I continue this, the other one has a y-intercept at B2. But they both have the same slope, the same steepness. That's what the slope is, the same steepness of the line. One other possibility for the relationship between two lines is that two lines may be perpendicular to each other. Two lines may be perpendicular to each other. So one is L1, for example, and the other one, let's say L2. L2. So this angle is a 90-degree angle. So if that is the case, the relationship between the slopes would be that M1, that is the slope of line number 1, would be equal to minus 1 over M2. So the slope of one would be the inverse with the opposite sign of the other line. So in that, let me just demonstrate this. If you have a line, for example, y equal 2x plus 3, this is line number 1, and you have line number 2, which is y equal 2x plus 10. Since these two lines have the same slope, however different intercept, that means these two lines are parallel to each other. These two lines are parallel to each other because they have the same slope. The slope is two different intercept, y-intercept. However, if you have L1 equal a line y equal 2x plus 3, and L2 is y equal minus 1/2 x plus 5, don't make any difference. Then these two lines, if you look at the relationship between the slope of these two lines, between 2 and minus 1/2, that is what m1 equal minus 1 over m2 means. So these two lines would be perpendicular to each other. Okay. As we said, one form of equation of a line is in terms of slope-intercept form, so mx plus b. Another form might be y minus y1 equal m times x minus x1. This actually becomes a formula when you have to find equation of a line when you have the slope and one point on the line given to you. You plug it in here and you get the equation of the line. Another topic in this chapter, before we get to the problems, another topic in this chapter is talking about domain of a function and range of a function. Domain and the range of a function. Okay? Domain has to do with the value of x. Over what value of x is the function defined? That would be the domain of the function. And based on the value of x, based on the domain of a function, what value does y take? What value does the function take? So for example, if you have y, which is a function of x, and is equal to 1 over x minus 3, for example, right? Then in this case, for this function to have a real value, the denominator should not be equal to 0. So x minus 3 should not be equal to 0. That means x should not be equal to 3. So the domain of this function is anywhere from minus infinity to 3, not including 3, and from 3 to infinity, again not including 3. So the only thing which is not included in this picture, in this domain of this function, the only thing which is not included in this domain is 3. And another time when the domain is limited is when you have square root. So one is when you have a quotient, next is the square root. For example, if you have a y as a function of x and it looks like square root of x minus 3. Okay? Now, when you have square root, or for that matter, when you have an even root, what you have under the root sign cannot be negative. So here you say x minus 3 has to be greater than or equal to 0 in order to have a real value for the function. So that means x has to be greater than or equal to 3. So if you want to write this in the form of interval that we have seen before, you put bracket 3, comma, infinity, close. Okay, so that's the domain of that function. Now, given the domain, then you say, okay, what about the range of the function? That would be the value of the function, or y, given the domain is limited from 3 to infinity. So you figure if you put 3 in this function for x here, if you put 3, that would be square root of 3 minus 3, which is 0, which starts from 0. So the lowest value y can take, is 0. That happens when x is equal to 3. When x is equal to 3, y would be 0. Since x has to be 3 or more, as x goes up, so would y go up. So as x goes beyond 3, y will go beyond 0. So the range of this function would be from 0, that is when x is equal to 3. It would be 0 to infinity. This is the range. This is the domain here. So there are basically two places where the domain of a function would be limited. One is when you have square root sign or even root sign, because you cannot have a negative under the square root or even root. And another one is when you have a quotient, right? When you have a denominator. Denominator cannot be 0, so you have to exclude that from your picture. So when you have a combination of these, by the way, if you have y as a function of x, and that is equal to, say, 1 over square root of x minus 10, right? So you have a quotient, you have a denominator, and you have square root. So because of the square root, this under the square root has to be positive. But at the same time, since it is denominator, it cannot be 0. So it should be greater than 0. Cannot be equal. So it has to be positive and not including 0. So that means x has to be greater than 10. So the domain of this function would be parentheses 10 to infinity. Close the parenthesis. This is the domain of this function. And in that case, the range, so let me see, this is the domain. Now the range would be, you say, okay, what if x here is equal to this, which is the minimum amount h can be? When x is equal to 10, or well, it cannot be equal because we have parentheses. When x starts from 10, this would basically be starting from a very small number, right? From very small number, right? The denominator. So something divided by extremely small number would basically be infinity. And as x increases, the denominator would get larger. And then 1 divided by a larger number would move towards 0. Right? So here, basically, the range of this function, range, would be from 0 to infinity. Now, we go to the book, the end of chapter 2, and look at some of the review questions. One more time, I would remind you that when you're looking at the questions that I have done on the modules and on the exercises, videos. The numbering might be different from your textbook because that was done from the 4th edition, and now we are using the 5th edition. So please make the adjustment. When you listen, I would explain the problem, then you would know which problem I'm talking about. It would not be too far from, so if I'm doing number 68, for example, you can see it would be somewhere in the low 70 or the other way to the low 60s. So somewhere between 60 and 70, that's where the problem is. It may not be exactly problem 68 in your textbook because of the change in the edition. So let's go to, if you have a book, page 149. Again, we are dealing with chapter 2, review exercises, and let's start with problem number 10. Problem number 10, and by the way, this in the 5th edition, it should be page 149. Page 149. So problem 10 says, find an equation of the line passing through the points. It gives you 2 points. 1 point with the coordinates of -1 and 3, and another point with the coordinates of -3 and 4. 2 points. Find an equation of the line passing through the point -1 and 3. I'm sorry, I read the questions wrong. Let's start again. Find an equation of the line passing through the point with the coordinates of -1 and 3, and it is parallel to this line that goes through -3 and 4, and another point of 2 and 1. Okay? So first we have to find this line, at least the slope of this line, and then find the equation for the line that goes through this, and it has the same slope as this one, which would be parallel to each other. So what we have to do is for this line explaining, the first one would be parallel to it, we have to find the slope. So m, the slope, would be equal to the formula y2 minus y1 divided by h2 minus h1 equal. Now you can take this as your first point and this as your second point. It doesn't make any difference. One of them first point, the other one second point. So y2 here is 1 minus y1 is minus 4 divided by h2, that is 2, minus h1, minus 3. So that would be equal to 1 minus 4 is minus 3, and 2 minus 3 would be 5. So the slope of the line is equal to minus 3/5. And since we want a line parallel to this line that goes through this point, parallel to this line with the slope of minus 3/5 and go through this point, then we have to use the same slope. So we want to go through this line, through this point, minus 1 and 3, and it's parallel to the original line. So we use this formula y minus y1 equal m times x minus x1. That's how you find the equation of a line. Now in this case, we have m, we have x1 and y1. x1 and y1 is referring to these coordinates, right? And this is your m. So y minus y1 is 3 equal m, which is minus 3/5, x minus x1 minus minus 1. So y minus 3 equal minus 3/5 times x minus minus 1 is plus 1. So y minus 3 equal minus 3/5 x minus 3/5 times 1 is 3/5. Therefore, y is equal to minus 3/5 x minus 3/5. Now take this minus 3 to the right hand side, it would become plus 3. Therefore, y is equal to minus 3/5 x. Now I combine these two together, minus 3/5, and instead of 3 I can write it as 15/5. So y would be equal to minus 3/5 x plus common denominator 5 minus 3 plus 15. So y is equal to minus 3/5 x plus 12 divided by 5. That would be the answer. That line would be parallel to the line that goes through the points of minus 3 and 4 and 2 and 1. Let's look at another questions. Question number 12. Question number 12. On the same page, review of exercises. It says sketch a graph of the function 3x minus 4y equal 24. Three x minus 4y equal 24. Since it is a line, all we need is 2 points. All we need is 2 points. Once we have the 2 points, we can graph it. Okay, so to do, I can put x here, I can put y here. One simple way of doing this exercise is give different value to x and figure out what y is. So for example, if x is 0, what would you have? You have 3 times 0 minus 4y equal 24. 3 times 0 is 0, so that is minus 4y equal to 24. Divide both sides by minus 4, y would be equal to minus 6. So when x is 0, y would be minus 6. That's 1 point. Another one, let's assume y is 0. Again, that's the easiest point I can find. So if y is 0, then you would have 3x minus 4 times 0 equal 24. 4 times 0 is 0, therefore 3x is equal to 24. Divide both sides by 3, x would be equal to 8. So having these, each one of these would give, each pair would give me a point. So this is, let's say this is point A, has the coordinates of 0 and minus 6, and point B has the coordinates of 8 and 0. So I can sketch a graph. If I have x here, and y here. First, I have to choose my scale. I see h goes from 0 to 8. These are the two values from 0 to 8. So I have to choose, let's say, my h this way. Let's say 2, 4, 6, 8, and continue. So 2, 4, 6, 8. And on my y-axis, I need 0 and minus 6. So let's choose, I can choose a different scale on that. So 2 minus 2, since it is below, since it is negative, will go to below the x-axis, minus 4, minus 6. Now, I can show the point A has a coordinate x of 0 and y of minus 6, right? X of 0, y minus 6. That means that point is right on the y-axis. This is point A. And point B has a coordinate of 8 and 0. That would be on x-axis, this point. If I connect, this is point B. If I connect these points together and continue, this is the line. So that's an easy way to sketch a line. Okay. Trying to find a variety of examples here. Question number 14. Question number 14 is asking you to find the domain of a function. If f of x is equal to square root of 9 minus x. Again, since you have a square root, what you have under the square root, this has to be positive or 0. So 9 minus x has to be greater than or equal to 0. That means minus x has to be greater than or equal to minus 9. Okay. Now, if I multiply both sides, multiply by -1 on both sides, so this would be positive. I have to flip the inequality sign. You remember that from the last section in chapter 1. So it would be x. Instead of greater than or equal to, it will go the other way, less than or equal to 9. I multiply everything by a -1. So that is the answer. So it goes from -infinity for x to 9, including 9. So that's how you write it in the form of interval. From -infinity to 9, right? And you can test it. Well, what simple value would be between -infinity and 9? 0, right? If you plug in for h0 here, for h0 you would have 9 minus 0, which is 9, and square root of 9 exists because it's 3. It's a positive number. So that is a domain of a function. Let's look at another example, talking about sketching a graph. Number 20. Number 20. It says let f of x. Oh, this is different. Well, let's do this. It's not a sketch in a graph, but this is when you combine two functions. It says let f of x be 1 over x, and g of x, so you have two functions, g of x equals 2x plus 3, and it is asking you to find the following. A, it says A, find f of x times g of x, f of x times g of x. Well, that is basically multiplication of these two. F of x is 1 over x, and g of x is 2x plus 3. So when you multiply these two together, you get x here, whoops, sorry, so you get 2x plus 3 divided by x. I mean, it's like given the denominator of 1 here, and you're multiplying these two together. Therefore, you get denominator times denominator, numerator times the numerator. So 2x plus 3 divided by x. B, it says f of x divided by g of x. Well, simple. F of x is what? F of x, right here. F of x is 1 over x divided by g of x, which is 2x plus 3. Give a denominator of 1 here. Now this 1 multiplied by this one will go in the numerator, so 1 times 1 is 1, and denominator would be this one times this one, so it is x times 2x plus 3, which would be ultimately equal to 1 over 2x squared plus 3x. So that is the two functions divided by each other. C says f of g of x, like that. Okay, I'm gonna write f of x one more time. F of x was equal to 1 over x. G of x was 2x plus 3, right? So f of g of x means evaluate your f function at the value of g of x. So I start with the f function here, and in place of x here, I put the whole of g of x, which means this whole thing. So therefore f of g of x is basically f of 2x plus 3. That means in place of x, I put 2x plus 3. That's f of g of x. That's evaluating function at certain points. Finally, it says D, it says g of f of x. G of f of x, that means you start with the g this time. You start with the g, and in place of x here, you put f of x. So it would be equal to, you start with the g. You start with the g. So it would be 2. In place of x, you put 1 over x. So 2 times 1 over x plus 3. Therefore, it is equal to 2 divided by x plus 3. That is the g of f of x. The g of f of x. Again, evaluating function at a certain point. Let's move to an application. Problem number 26. The cost and revenue function for a certain firm are given by, the cost is given by this function, 12x plus 20,000, and revenue is given as 20x, respectively. Find the company's break-even point. The break-even point. Break-even point. Okay? Break-even point is where the cost and revenue are equal, or in other words, profit is 0. When the cost and revenue are equal, profit would be 0. So you're saying C of X would be equal to R of X. Cost equal revenue. C of X is 12x plus 20,000. That should equal R of X, which is 20x. So you have to solve for X. Bring the X to this side, so you would have 12x minus 20x equal, take the 20,000 to the right hand side, it would be minus 20,000. Therefore 12x minus 20x is minus 8x equal minus 20,000. Divide everything by minus 8, x would be equal to minus 20,000 divided by minus 8 is how much? X would be equal to 500, 2,500, 2,500. So for number of units of 2,500, the company would break even. That means cost would be equal to revenue. When cost is equal to revenue, profit would be 0. Profit, which is the difference between revenue and cost, would be equal to 0. Let's look at another application. Company sales. Problem number 30. Problem number 30, company sales. A company's total sales in millions of dollars are approximately linear as a function of time. Sales in 2004 were $2.4 million. So in 2004, sales was 2.4 million, whereas sales in 2009, sales were 7.4 million. Find an equation given the company's sales as a function of time. The company's sales as a function of time. Okay? So we want sales to be a function of time. In order to find the function, we need the slope of the line and we need 1 point on the line. One thing we can do is we can say, let's take a base year which means where t standing for time would be equal to 0. The base year is 2004. Right? So you say, instead of saying 2004 sales is equal to 2.4 million, you're saying when t is equal to 0, sales is equal to 2.4 million. Okay? So when for 2004, if t is equal to 0, what would it be for 2009? Another point we know we have information about. For 2009 would be 2004 is 0, 2005 would be 1, 2006 would be 2, 2007 would be 3, 2008 would be 4, 2009 would be 5, right? So when t is equal to 5, therefore, sale would be 7.4. So I have 2 points here. Given the 2 points, I can figure out the slope of the line. Again, I'm trying to find, it says find, the question is find an equation given the company's sales as a function of time, right? So I need the slope. Formula for the slope was y2 minus y1 divided by h2 minus h1. So in this case, let's say this is my first point, this is my second point, right? So y2 would be 7.4 minus y1, which is 2.4, right? Again, this is like my x, this is like my y, because it's sales a function of time, divided by h2, which is 5, minus 0. So m, therefore, is equal to 7.4 minus 2.4 is 5, divided by 5 would be equal to 1. So the slope is equal to, the slope of this function would be equal to 1. As I said before, the formula to find the equation of a line, is y minus y1 equal m times h minus h1. So I can take any of these 2 points, either this point or this point, to be my x1 and y1 and plug it into this formula. So y minus, let's take the first one, that seems to be the easier one. Y minus y1, that would be 2.4, equal m, I already calculated to be 1. H minus h1, in this case, or t, is equal to 0. So y minus 2.4 equal 1 times x is x. Therefore, y is equal to x plus 2.4. Okay. Then the next question says, what were the sales in 2007? Okay, so again, understand that X is referring to time and Y is referring to sales, right? So in 2007, what is time? What is X? No, if I want to convert this into sales and time, so sales, which is Y, is equal to time plus 2.4, right? Time plus 2.4. So in 2007, what is time equal to? Again, remember 2004, T was equal 0. So 2007, T would be equal to 3. So sale in 2007 would be equal to 3 plus 2.4, which means it is equal to 5.4. So that's how you find the equation that shows a relationship. By the way, right here, instead of Y and X, these are variable. X means time, Y is sales. I could have used S and T, so S equal T plus 2.4. Either one, it would have been the same. I can identify what variables I'm going to use, and I said up here, I said X is time right here. I said X is time and Y is sales. So that's why I went ahead and used X here and Y here. So it would correspond to this table I have in front of me. Another problem is linear depreciation, like problem number 32. Problem number 32, linear depreciation. It says an office building worth $6 million when it was completed in 2005. In 2005, the building was $6 million. Is being depreciated linearly over 30 years. Over 30 years. Depreciated. That basically means the value after 30 years it will go down to 0. It doesn't tell you anything about salvage value at the end of 30 years. So we assume it is 0. What is the depreciation rate? The depreciation rate is basically the slope of the line, right? So I can say that the value of the building value is a function of time. Value is a function of time. And this is a linear function, right? It's a linear function. From 2005, for 30 years, it's gonna go from 6 million to 0. From 6 million to 0, right? So when t is equal to 0, at the base year in 2005, when t is equal to 0, the value is equal to, when t is equal to 0, the value is equal to 6 million. 30 years later, when t becomes 30, the value would be all the way down to 0. Okay? Now, I can go ahead and calculate m and then plug it in the formula like we did in the previous problem and solve it that way. Or I would realize that when t is equal to 0, remember your graph is like this. Here is t, here is the value, right? Your function starts from the value of 6 million, and it goes down. And when it is 30 years, whoops. How do I get rid of this? Delete. So in 30 years, the value will go back to 0. So I can see the slope here, the intercept is at 6. What is the slope? When the building of $6 million depreciates over 30 years, the slope, I can basically figure it out. The slope would be equal to 6 divided by 30. Okay? Which is equal to 1/5. 1/5 of a million, right? 1/5 of a million. Or 200,000. Right? So the value, therefore, the value would be equal to 1/5 times t plus 6. By the way, it is a minus 1/5. Minus 1/5 t plus 6. So the rate at which the building is depreciating is 1/5 of $1 million per year, or 200,000. I could have written this in dollar amount. I could have written this in dollar amount, and V would be equal to minus 200,000 T plus 6 million. I could have done it like this. So you can put different value for T from 0 all the way to 30, right? All the way to 30, and figure out the value of the building at any given time. One more problem I want to do in this review, and that is problem number 36. Problem number 36. College admission, it says. The accompanying data were compiled by the admission office of Carter College during the past 5 years. The data relate the number of college brochures and follow-up letters X sent to pre-selected list of high school juniors who took the PSAT, and the number of completed application Y received from these students, both measured in thousands, right? So you have two variables. I'm going to write it vertically. The book has it horizontally. So you have X here and you have Y here. And the numbers, X referring to the number of brochures, and in application completed is Y. So you go from 1.8, and y would be 0.4. When you send 2,000, you get 0.5 completed. That's 0.5 of 1,000, that's 500. When it is 3.2, it is 0.7. When it is 4, it is 1. When it is 4.8, it is 1.3. Okay, so you have that information. By the way, each pair of these numbers on the graph would give you 1 point. Each pair is 1 point, right? So this table would give you 5 points, each point for 1 year, right? Because this is for the past 5 years. Each point is for 1 year. Derive an equation of the straight line L that passes through the points with the coordinates of 2 and 0.5, with the coordinates of 2 and 0.5, so this point, and 4 and 1, and this point. So we are ignoring everything else, and we are using these 2 points to come up with the equation of a line, right? Apparently not all these points fall on a straight line. That's why they chose 2 particular points and say, okay, find these 2 points and make your straight line a linear, right? So you want to find an equation of a straight line. Again, the formula to find the equation of a line is y minus y1 equal m times x minus x1. So first you need the slope. Taking those 2 points, the slope would be equal to, again, formula of y2 minus y1 divided by h2 minus h1. So one of them the first point, the other one the second point. So y2 is 1 minus y1 is 0.5. h2 is 4 minus h1, which is 2. Therefore, m is equal to 0.5. That is 1 minus 0.5. 4 minus 2 is 2 equal. Now, 0.5 divided by 2 is what? 0.25. That is the slope. That is the slope. I can take this slope and one of these lines, let's take this line to plug it into this formula. So I will go y minus y1, that would be 0.5, equal m, I found it to be 0.25, times x minus h1. h1 is related to this 0.5 is 2. So y minus 0.5 equal 0.25x minus 0.25 times 2 is 0.5. Okay. I guess everything is correct. So y equal 0.25x. This minus 0.5 and this minus 0.5, they would cancel each other on the two sides. Therefore, y is equal to 0.25x. Right? That is the number of applications completed as a function of number of brochures sent. 0.25 of x. So a quarter of the people who received the brochure, a quarter of them would complete the application. That's what it means. A quarter of the people who received the brochure would complete the application based on those 2 points. use this equation to predict the number of completed application that might be expected if 6,400 brochures and follow-up letters are sent during the next year. 6,400. Now understand, when we did this, the number of brochures, this X, the numbers are in thousands, right? So 1.8 thousand, 2,000, 3.2 thousand, 4,000, 4.8 thousand. So in this, when we plug in for X, you don't put the whole 6,400. X in this case would be 6.4. Therefore, Y would be equal to 0.25 times 6.4. Okay, so Y therefore is equal to 6.4 times 0.25, or 6.4 divided by 4. It is what? 1.6. Right? So if you send is 6,400 brochure, if you send 6,400 brochure, 1.6 thousand, which means 1,600 completed application would result. So 1,600 people would respond to that and apply and send the application fee and whatever to apply to your college. Well, I hope this review helps in understanding the material in Chapter 2. And again, don't forget the modules you need to study, the exercises you need to study. When you go to media library on the ebook, you can watch more video teaching these different problems, and that all those tools should help you greatly in success in this class. Thank you.